Okay, so thanks everybody for coming to this session. We're going to speak specifically about ProxySQL cluster, the way it works, and the challenges that we face while during the implementation of it. A very quick introduction. Who am I? My name is Rene Cannao. I am the founder of ProxySQL, both the product and the company. Historically, I am a MySQL DBA for most of my career. Just a quick note about our company. What we do is we basically provide support for MySQL, ProxySQL, and we also do DBRE and consultancy. And of course, we do the development of ProxySQL itself. As everybody else in this conference, we are hiring. So we are looking mostly for C and C++ developers, but also for some MySQL DBA, DBRE, and so on. But mostly, the most important one is C and C++ developer to work at the ProxySQL code base. Okay, now quick note about ProxySQL from where it comes and so on. So the main idea is that historically you have an application layer that is handled by a certain group of people inside a company, and then you have another layer that is the database, and those two layers often are completely separated from each other. They just work in a different way, and they communicate through some protocol. And in this case, often is the MySQL protocol. And yeah, there is a lot of interaction between them, but there is not much control over it. So the idea behind ProxySQL was to create a reverse proxy that just sits between those two layers and is able to intercept the traffic and performs various transformation and alteration of the traffic and control of the traffic itself. I'm going to give a very quick introduction because this is not the main topic of the session. So in short, what is ProxySQL? Is a proxy for MySQL that is protocol aware, so it understands all the queries that are passing through it, and based on certain criteria, it performs certain action. It could be to either decide where to send the query or perform any other sort of operation on the same. If you want to know more about the product, just visit our website. It is proxysql.com. Okay. Main feature of ProxySQL, if you are already familiar with it, you're probably start using it for one of the features listed here. Those were, again, the main one, the reason why it was created in the first place. And so they're like high availability and scalability, firewall, query throttling, query rewrites, and so on. It natively support a lot of replication topology, that is standard MySQL replication, or also Galera, PXE, group replication, and Aurora. By default, ProxySQL is replication agnostic, so it doesn't know anything about replication. So it doesn't really care if there is any replication between the servers that are configured behind ProxySQL. So it doesn't really care, but if you configure some specific monitoring check, then at that point it tries to become aware of what sort of replication there is between the server and performs the relative checks. Here there is another list of features that are important in ProxySQL, like ability to perform real-time statistic, mirroring, so you can send traffic to a set of server and they are automatically mirrored somewhere else. Data masking, there was a session this morning with example. One of the most important features that is often used is connection pooling and multiplexing. This often is able to drop the number of connections by up to 95%. It really depends on how you configure it, but it's not uncommon to see 95% drop of connection. And one single ProxySQL instance is able to handle 1,000 of database server as a backend. Again, I want to stress the fact that there are hundreds of database server, not hundreds of connections or thousands of connections. So the number of database server that can handle is quite big. So it's not uncommon to have a deployment in which you have hundreds of proxies, and each proxy is handling hundreds of database server. The main topic for this session is the native clustering features of ProxySQL, what is and exactly for what is used. We are going to dive into the rest of this session. Now, before speaking about the ProxySQL clustering, it is important to define where you normally deploy ProxySQL, because based on this, you can then define the various strategy that you have with regard to configuration management and so on. So one of the quite common deployment of ProxySQL as topology is to install ProxySQL locally on the web server or on the application server. I said web as an example, but it could be any sort of application server. So what are the pros of this approach? Well, the pros is that basically you don't have any network overhead, because the communication between the application and ProxySQL is basically at no cost. There is no network involved. There is no single point of failure. So, if you have the application and the proxy locally, they're communicating on a local instance. If one of them dies, you basically have the whole pair that is gone, unavailable. So no matter if it is one application that goes away or ProxySQL that goes away, they fail together, but the rest of the infrastructure keeps working. The configuration is quite isolated. I mean, you can have the configuration specific to that host. And another benefit is the rolling upgrade. So, if you have a fleet of servers and you want to run the upgrade, you can upgrade one by one, of course, with the right automation, but you can perform a rolling upgrade without any interruption, basically. So it has no big impact. What are the drawbacks in this sort of configuration? Well, because every proxy has to monitor the backend, you have way more overhead on the database server, because each proxy has to perform several health checks on each database server. Now, because each proxy will have its own connection pool, this often results in more connection being created to the database server, because you have more proxies and each proxy has its own connection pool. Configuring, making sure that all of them are using the same configuration, it required some effort, but it's nothing too complicated. And the other drawback is if you're using query cache in ProxySQL, the cache in one proxy cannot be used by client of another proxy. So basically, every proxy will have its own cache. Now, another deployment, deployment that is possible, is to have ProxySQL as a standalone server that physically sits between the application and the database server. So not on the application server, but neither on the database server. So the benefit, the monitoring overhead on the database server is gone, because now there is only one proxy doing all the monitoring. Less backend connection for the same principle. There is just one proxy that does the connection pooling. The query cache is shared, so that's also a benefit. And the configuration effort is less, because you basically have to you have to configure just one proxy. What are the drawbacks? Well, you have an additional network round trip, so you have some extra latency, single point of failure, because just one proxy there, and you cannot do any rolling upgrade if you have only one server. Of course, there is no need to say that this setup is normally not used, because one of the drawbacks is that it's a single point of failure. So it defeats the purpose of having a decentralized series of proxy. So you actually do not use this sort of setup. A quite common setup instead of is something. Let me just make a note about this. What you can have here is actually to have multiple proxies that are in the middle layer, but this is a bit out of the scope of this session. Another deployment that is quite common is to have ProxySQL in the application server and as a middle layer. We have quite big customers that also have a completely different setup in which ProxySQL is actually in the database server. So they manage all the failover and so on, and what they use ProxySQL mostly for multiplexing. So actually, their setup is that ProxySQL is installed on the MySQL server. Okay. Now, next. So as I was saying, ProxySQL is a proxy. So the main idea is that it should try to be as decentralized as possible. So you can have proxy spread all across your setup. So do not try to have just one proxy instance, but try to aim to have as many instances you have. And those instances, they need to be able to communicate with each other, and they should behave in the same way. So like if you have a situation in which you're using something like Galera, all of them they need to write on the same server and not on like a set of proxy writing on one server and another set of proxy writing on a different server. So they need to communicate somehow between them and make sure that they have the same configuration. Also, if we have this setup that is extremely distributed, what we can achieve are a series of advantages. One is basically scalability. This infrastructure should be able to scale technically without limit. We have customers using hundreds of proxies. They are all spread across their setup, and for the same reason, this should provide redundancy. So like any instance can die at any time, and there should be no downtime. So the main topic of this session is about ProxySQL cluster, and specifically with regard to configuration management. So quick note: what is a configuration management? Is basically a set of software tools that allow to maintain the system in a specific state. That is the desired state that you want. So basically, all the nodes should be configured in a certain way. The configuration management should make sure that this configuration is consistent. Again, all the nodes should have the same configuration, and of course should be according to your specific requirement. So like if you want configure it in a certain way, and those are your business requirement or your configuration requirement, all the nodes should be converged to the same configuration. Great. Now, are there configuration management software out there for ProxySQL? The answer is yes, there are several. I'm going strictly in alphabetical order, so not based on preference or whatever, just in alphabetical order. Ansible is the first one. This is the website where you can get the Ansible Ansible for ProxySQL. As you can see, there are multiple modules for Ansible and ProxySQL. The fact that there are so many modules is basically an evidence on how many module of ProxySQL you can configure through Ansible. But at the same time, it also tells you that ProxySQL is extremely configurable. So you have the backend server, that is to add and remove servers, global variables, info, manage config, user, query rules, and so on. So basically, it has a lot of modules to configure the various parts of ProxySQL. Now, again, strictly in alphabetical order, then we have Chef. Again, this is the website where you can get the Chef cookbook for ProxySQL. I won't go in details, but the idea is similar to Ansible and others that we are going to show soon. So basically, there is a series of tools that is able to configure ProxySQL according to your requirement. Then we have Puppet. Yes, then we have Puppet also. This one is extremely popular to configure the various elements of ProxySQL. And I think the Puppet is the most popular at the moment, considering the amount of download. I think is the most popular one. Okay, so this was the list of configuration management tool that is commonly used for ProxySQL, but this is not the whole story. Like, you can also have some service discovery tools like Console that can be used for ProxySQL to configure ProxySQL. So basically, in this case, what you will have is a series of console server that are constantly exchanging information and heartbeat between each of them. There is one that is becoming the leader, that is the source of truth between the cluster. When you want to make a configuration change, you just push this new configuration to the console leader. All the other console server will get a notification, and then this configuration will be notified and pushed down to the console client. Then what you normally have is the console client is the one responsible for connecting to ProxySQL and reconfigure it. ProxySQL is extremely reconfigurable at runtime, so just connect to the admin interface and reconfigure it through a series of SQL commands. Without going into details, same things apply to Zookeeper, very similar concept than console. So you have a leader, a series of servers that they exchange the configuration, and then this configuration is pushed down to a client, to a Zookeeper client, and then this client is the one responsible for configuring ProxySQL. Now, no matter the fact that there are a lot of those tools, we also have our own implementation for configuration management. It is called ProxySQL cluster. It has several benefits compared to all the others. The main benefits are the one listed here. So first of all, it doesn't rely on any third-party tool. So you don't need to use Chef, Ansible, or whatever. You just can use ProxySQL itself to configure all the ProxySQL instance within your infrastructure. Also, because we are the one maintaining it, when we make a new release of ProxySQL and we release a new features, ProxySQL cluster immediately support these new features. While if you are using third-party tools, it might take some time for the implementation of these new features. And there are other enhancements related to ProxySQL cluster, but I'm going to describe them later on in this session. Now, what ProxySQL cluster is able to synchronize? Basically, at the moment, is able to synchronize everything inside ProxySQL. So this means that it's able to synchronize MySQL users, MySQL server, all the MySQL server replication topology. So if you're using Galera, async replication, whatever, it is able to synchronize those. In the past, this was not always the case. We were implementing features, and ProxySQL cluster was able to synchronize them a few minor releases later. But now we make sure that every time we implement the new features, ProxySQL cluster support it immediately. MySQL query rules, ProxySQL node themselves. So like if a ProxySQL node is part of a cluster, all the other nodes are aware of which are the node in the cluster. Now, about variables. In the past, we were not able to synchronize variables, like the admin variables and the MySQL variables, to make an example. The reason behind this was the fact that we were able to add new variables on every new minor release. And because of the way ProxySQL cluster synchronize the variables, I'm going to show this later on in more details, but it basically verified that the configuration in one node is identical to the configuration of another node. But of course, if one node has a variables that the other node doesn't have, they will never be identical. So they were potentially ending up in a situation in which they were constantly checking each other, constantly seeing that there was a difference, but where they were never able to synchronize. Now we solved this issue in a very simple way, and I'm going to describe this in more details later. But basically, in short, the way we solve this is that to form a ProxySQL cluster, all the nodes must be on the same version. So basically, when they connect one to another one, they check the version. If they see that the version is not the same, they just do not peer to each other.
Is that minor versions also?
Yes. So if you're running 2.3.1 and 2.3.2, they are not able to pair. Okay, so how does it look? A very basic cluster topology, ProxySQL cluster topology. Here is an example. You have one proxies. That is the one where you are making the configuration changes, and you have a series of other proxies that are just pulling the configuration from it. When they pull the configuration, well, basically what they do is that they constantly check if the main proxy has a new configuration, and as soon as they detect a new configuration, they wait a certain period of time to make sure that their configuration has changed, that the configuration of the source hasn't changed again, and when they realize that, okay, the configuration looks stable, they will pull it. Of course, this diagram like this has a problem, has single point of failure, and of course, this is not the way you normally deploy ProxySQL cluster. The way you normally deploy is something like this. So basically, you will have a series of proxies that are basically monitoring each other. And as soon as you make any change in any proxy, the other will detect it and will pull the configuration from it. Now, few important things to note here is that there is no leader election. So you can actually write on any of the nodes, and all the other will get the change. This also means that you can write the same configuration on 2 nodes at the same time, and they will still all converge to the same point. Now, it is time-based synchronization. This also means that try to avoid making configuration change too often, because it can lead to conflict. We managed to solve a lot of possible conflict, and I will show you also why those conflicts were happening, and some incorrect use of ProxySQL cluster, but you will see this in a few slides. Okay. Now, if you're familiar with ProxySQL, you know that basically all the configuration is in tables. ProxySQL cluster is not different. So you have a tables called ProxySQL servers, and there you have a list of all the proxies that are part of the core nodes of ProxySQL cluster. So in this example, we have 4 proxies that are running on locally on the same instance. The reason why I brought up this example of 4 proxies all running on the same server is for the fact that here we have 4 different ports. So the host name is the same, so they all have the same IP address, but they have 4 different ports, and they are still able to synchronize between each other even if they have a different port. This becomes relevant if you are aware of how you configure in which port ProxySQL has to listen. And so, if you're listening on port 6032 and they are all listening on port 6032, when they try to synchronize, they will be trying to switch on port 6032. But this example shows that we have a workaround for it. So you can have multiple proxies on different ports, and they are still able to synchronize between each other. Now, there are a lot of variables that define how a ProxySQL cluster, how the node in ProxySQL cluster are able to synchronize. This is not the full list of variables related to ProxySQL cluster, but they are the more important one. Because of how ProxySQL cluster works, is that each node will have to connect to the admin interface of the other node. So of course, to connect, they need credential. So here you have the username and password as part of admin variables. Also, they are going to check each other at regular interval. So there is a variables that define this interval. In this case, and this is also the default, they're going to check each other at regular interval of 1 second, 1000 milliseconds is 1 second. Now, the next set of variables that we are seeing here is basically a variable for each module that is synchronized in ProxySQL cluster. So you have a variable called, for example, admin cluster MySQL user diffs before sync. So what this controls is that when nodes are checking each other, when they detect that the MySQL user table has changed, they wait 3 checks. And if after 3 checks, the configuration is again changed the way they detected in 3 checks previously, they trigger the pull of the configuration of the MySQL users. Is this clear? Yeah. Okay. In other words, the changes have been finished before it's exactly. This is why you have to wait. I'm going to show you later on, but one of the horror stories, but basically this is the point. Like if you put the interval too small or the diff checks too small, you might end up in a situation in which you trigger a synchronization before you finish the change. So this is why you have to wait a certain period of time to make sure that the synchronization is that the change in one of the nodes is completed, because otherwise you might end up in a situation in which you're pulling a configuration before it's finished.
So this configuration takes 3 seconds to synchronize?
Yes. And things can go bad also in this case, because you can have situation, but I have a slide for it. You can have a situation in which after 3 seconds you're actually making another change. So I'm going to that specific case soon. So ProxySQL, we have configuration in tables, but we also have statistics in table. So we have a table that is dedicated to show what is the status of the cluster, specifically how the configuration is in the cluster. The table is called stat ProxySQL server checksum. And here what you can see is that for each node on the cluster, you have the hostname and the port. Then you have a column called name, that is basically the name of the module that need to be synchronized. So you see admin variables, MySQL query rules, MySQL servers, and so on. You have a column called version. I'm going to go into the details later. Epochs, checksum, check.that, update, and diff check. Now, there is way too much information here, so let's just zoom in one specific on one specific module. In this case, the module is the MySQL server. So here we are seeing 4 nodes. So we see the hostname and port. The name is identical for everybody. It is MySQL server. The version is important. So every time you are executing load MySQL server to runtime, in this case, every time you're executing load MySQL server to runtime and the new version of MySQL server is loaded to memory, this version is increased by 1. The version is increased by 1 also if you have a situation in which ProxySQL cluster itself triggers a resynchronization. So every time a new configuration is loaded at runtime, the version increased by 1. Then you have the epoch. This is the epoch of when this specific configuration was created. Historically was when it was applied, but we had an issue there that created some issue, and I'm going to describe it later. So now the epoch is when that specific configuration was created. Then we have the checksum. This is the checksum of the configuration itself. So like in the specific case of MySQL server, you can have 100 of servers. You can have 100 of cluster configured in MySQL replication host group, or you can have dozens of Galera cluster configured here. So to make the comparison between ProxySQL cluster nodes, what we do is we generate a checksum for each module. So all the proxy need to configure to see if they are in sync is to check if the checksum is the same. If the checksum is different, it means they are not the same, and they need to put the configuration from each other and basically update it. Then we have the change.that. It's basically when this configuration was changed. And because each proxy is constantly monitoring each other, they also have when this was updated. So updated.that is when this metrics was updated. So when they got a notification from another proxy that this is their checksum. So basically, if nothing changed, enough configuration change, what you're going to see is that updated.that is basically increase of 1 second every time. Like every time you are querying it, updated.that is the only column that should change. Defs is basically shows the configuration of that specific node. If it is different from the configuration of the querying node, that is basically where you're running this query. If the diff increases, it means that the other node has configuration different, and it counts the number of checks in which the configuration was different. Now, one important thing to know about the version number is that, as I was saying, every time you're loading to runtime, this increased by 1. And if you have a ProxySQL that just started, the version is 1 because it executed internally load to runtime just once. So once has a special meaning. It basically means that the node just started. And because 1 has a special meaning, ProxySQL knows also that it should never sync from a proxy that has a version number 1. Let me explain why. Let's assume that you have a cluster that is running for a long period of time, and it has some configuration. And then you start a new proxy that just joined the cluster. This proxy will have version 1. And it will have the epoch that is newer because his configuration is newer compared to all the others, because the others are running for weeks. So the version number 1 is a fancy mechanism, because now the other proxy knows that even if the new proxy has a configuration with an epoch that is bigger than everybody else, his version is 1. So probably it's a new server, so they should never sync from it. So it's a fancy mechanism. That also means that if you start a series of proxies at the same time, like you have no cluster and you start all the proxies at the same time, they will all have version 1, so they won't synchronize until you execute at least load MySQL server to runtime to one of them. As soon as you run this, they will start synchronizing. Going back to what I was mentioning before, like you need to configure the interval millisecond and all the various diff before sync accordingly, because if you are configuring them too aggressively, you might end up in a situation in which proxy are just trying to configure from each other way too fast than they should. Now, poor design pattern.
Is there a way to stop synchronizing one of the modules?
Yes. You just set this one of those to 0. Like if you don't want to synchronize the MySQL user, you just set these variables to 0, and it will never synchronize. Now, some weird horror stories. So the fast synchronization, this was something that I already mentioned. Like if you configure the synchronization to be too fast, you end up in a situation in which you are basically pulling a configuration that is not completed yet. Another one is combining ProxySQL cluster with another configuration management tool, and that they might make changes at the same time and often conflicting. This does not mean that you cannot use another configuration management tool while using ProxySQL cluster, but if you do, just make sure that the configuration of ProxySQL cluster is not too aggressive. So if there is console or anything else that is changing ProxySQL, make sure that ProxySQL cluster does not trigger the configuration way too fast. Another interesting issue that we have seen on our customers is that they were having a set of proxies using the same CNAME. This was creating some very interesting problem. So basically, you end up in a situation in which one proxy was connecting to another proxy, detecting a configuration change, but because all the CNAME was mapping to all the proxies at the same time, then when the same proxy was trying to connect to the proxy where it detected the configuration change, in reality was connecting to another proxy. Yes. So this was a problem. We solved this, and I'm going to explain soon how we solved it. The same thing was happening when I've seen setup in which there were a set of proxies behind the load balancer. So absolutely the same problem. One proxy believes it was communicating with one proxy, detect a change, and then it creates a new connection, thinking to connect to the same proxy, but in reality it was connecting to another one. So it was pulling the wrong configuration. And this created a situation in which configuration was actually getting rolled back, because depending to which proxy it was connecting, it was getting an old configuration. We solved this. The way we solved is basically, I have a slide for it, so I will explain it later. So before I was showing that you can run multiple proxies on the same server, but on different port. The way we do this is that we define the new variables called the ProxySQL sync interface. If this variable is set to false, it will not synchronize any variables that is relevant to where the listener are listening. Of course, this variables is not part of admin variables because it cannot be synchronized. So like there is defeat the whole purpose. So it is actually a configuration that can only be changed in the configuration file. And the other issue I was saying before, we are now able to synchronize variables thanks to the fact that ProxySQL nodes are able to pair only if the version is the same. If the version is not the same, they just stop peering. Okay, next. So before I was showing this diagram in which you have one main set of proxy and other proxy that are able to configure to put the configuration from them. So you can change the configuration on any of those two proxies, and the other will take it as well, and also the other three. But you can have way more complex diagram. Like again, the two there in the center are the main one, and you can change the configuration in any of them, or even on both of them at the same time or slightly different time. They will detect that. Like it can happen that one of the proxies detect the other one has changed configuration, but then if you apply the same configuration to it, they will say, okay, we now have the same configuration. There is no need to synchronize, but all the other proxy will get it. Now, I'm very bad at doing graphs, so instead of polluting this slide with way more proxies, we can simplify things like this. So we actually have two types of proxies in ProxySQL cluster environment. One that is part of the core layer. It is basically the set of proxies that where you are making the changes, and the set of proxies that are satellite. So the satellite layer, in which you do not change the configuration on them, but they are only the one pulling the configuration. So this allows to scale very well because, for example, in the core layer, you can have just 4 proxy, and they are the one that are checking each other. But then in the satellite layer, you can have hundreds of proxies, and they do not check each other. They only check the 4 proxies that are in the core layer. So this setup can easily scale to 100 or even 1,000 of instances. There is absolutely no problem in the number of instances you can have. Now, what we introduced recently is the fact that when a proxy is connecting to another proxy, it also registers itself. Let me describe this better. So in the diagram that I had here, where I was saying that in the satellite layer you can have hundreds of proxies, what each of those hundreds of proxies has is just a ProxySQL server table configured. So they know which are the 4 proxies that are part of the core. But the proxy in the core, they know nothing about all the proxy in the satellite layer, and they can be 100. So now what we introduce is the fact that when a proxy connects to another proxy, it also registers itself. Basically, it generates a UID. It is automatically generated and is also saved on disk. So we have a new table called global setting. Right now, there is just UID. It is automatically generated, or you can change it here or in the configuration file. And when a proxy connects to another one, it basically registers itself, sending this UID. Why it is useful? Because now we have a table called, names are getting long, stat ProxySQL server client status. So now basically this is the list of ProxySQL clients that are connected to the ProxySQL servers. So here we have a list of UID from where they are connecting and from which port they are coming from. Also, when they connect and they register themselves, they do not just send the UID, but they also advertise what is the admin MySQL interface. So this means that from this ProxySQL instance, I now know also how to connect back to the other instance.
Do the core nodes synchronize this data?
No.
But you just register your satellite to all the core nodes?
Correct.
They have the same data.
Correct. They should have the same. If they do not have the same, probably you have some network issue. And here is a slide that summarizes why we introduced these features. So basically, it's very common to have ProxySQL, in some auto-scaling environment. So while the satellite layer can grow a lot, In this way, you are basically able to track what are the proxies that are part of the cluster. So say, okay, you have 10 or 100 or 200, but now you know how many you have. And also in this column, in this table, you also have a column called last seen at. So this column is updated every time the client is sending a heartbeat. Heartbeat can be anything. It could be just checksum check or a pulling of configuration. Any type of query that is being executed by the client is counted as a heartbeat. So this, every time it sends a query, last seen at is updated. So now we know exactly what is part of the work cluster. We can improve monitoring based on this, because just to make an example, what we can do is we can have a system in which we have some agent that monitor this table, and when it detects that there is a new ProxySQL cluster that is now part of a new ProxySQL node that is part of the cluster, they can get the information from that server and register that server in Prometheus, for example. So now you can have Prometheus that is able to connect to the Prometheus exporter on that specific node and get metrics from it. Now, in the futures, we're also planning to have the ability of the ProxySQL core nodes to connect to all the satellite node and get metrics from them. So basically aggregate all those metrics within the core. And if you have a complex setup, this can be also extremely useful for troubleshooting. Like if you have some traffic that is not happening as expected, now you know all the proxy that are part of the cluster, so you're able to troubleshoot more easily. We are also going to release very soon a web UI, and the web UI, this information plays a role important there as well, because from the web UI you will be having the ability of choosing to which proxy you want to connect. So basically the idea is that you connect to any of the proxy in the core node, and from there you will see the list of all the proxies that are in the satellite layer, and you can just tell the web UI, okay, now connect me to that specific ProxySQL instance, and you can either configure that as a standalone node, or you can troubleshoot or get graphs from it, and so on. Okay. Now, what is still on our to-do list is to have some leader election. It is not a strong point in our to-do, in our priorities, because the way cluster works right now does not really need a leader election. But so this will be like an enhancement, but it's not a requirement. The interesting part is that we already have a lot of parts that can play together to make the leader election easy to implement. Specifically, right now, admin can already be in a read-write mode or in read-only mode. This is a feature that is not well known because there is no much use case for it, but this is already possible. Not only this, it is also able to reply to queries like select read-only. So basically, we can use the same type of check to configure a replication host group. So we can have something like having all the ProxySQL instance configured into host group, a writer host group and a reader host group. So this will allow us to do something like you connect to any of the proxy, and you will be automatically redirected to the host group where the writer is. So this will allow us to connect to any of the proxy, and you will be able to make a configuration changes in the leader. Now, the satellite, you do not set anything in the satellite because the satellite are not active part of the cluster. So they do not have anything in the ProxySQL server table. Sorry, they are not in the ProxySQL server table of other proxies. So what you do is that if you have 4 proxy in the core, you configure 3 of them as read-only and 1 of them as read-write. And because they will be able to monitor each other, running select at read-only, they will automatically know which one is the writer and which one is the reader. And if you perform a failover, let's say, you're just changing the leader, they will automatically detect which one is the new leader, and so they will reconfigure the host group making sure that there is a host group with only the writer.
I'm just thinking for a case where developers get the bright idea to change configuration and it's local proxy on that server. You could put all the satellites read-only by default.
But this is why you will have this table is now useful, because if you make a configuration change on a satellite, now from the information in this table, you're able to connect to all the satellites and figure out if they have a configuration mismatch. No. But with the information here, you can easily connect to all of them and figure out if there is any proxy that has a configuration mismatch. The 4 are also in this list, because when they connect to another one, they are a client of the other proxies. And because they monitor each other, so each of them is also a client. And for example, this one. Oops, sorry. This one. This one is one of them. Okay, so I was going to say some weird issue that we saw in the past, and we had to work hard to make it work. So like you can have situation in which the synchronization itself is slow. It could be for a variety of reasons, like network delay, like network is being congested, or because there is a very complex configuration. And especially with the MySQL query rules fast routing, it is very likely that you have a table with millions of rows. So if they have to synchronize, it might take some time. And or also we can have situation in which you are running a complex query on admin, and it is causing some internal locking. So the synchronization itself becomes slow. And we have seen cases in which this could lead to configuration rollback, and I'm going to describe now exactly actually two examples of how this happened. Now let's assume that you had all the proxies that like 4 nodes, all of them with the same configuration. Right now I call it like configuration 1. And then you change the configuration in one of the proxy, like you change the configuration in A, and B got the configuration immediately, while C and D, they didn't got it yet, for whatever reason, like they are busy in doing something else, or the configuration is too big and just takes some time to process it. Now, you can have a situation in which now C finally get the configuration that you applied previously in A, but at the same time, A get a new configuration. So the configuration in A is 3, while C and D is still 2. And let's assume that node B also get the configuration from A quite fast. Now, what problem we face in the past? Now, because there was a delay between when the configuration number 2 was applied to A and when C finally applied that configuration, it is possible, just a timing issue, that the configuration in C was executed after you made the configuration change in A. And if the configuration is only time-based, what the cluster will think is that the configuration in 2 is actually newer.
Is it possible, so the server startup is 1, right?
Yes.
So let's say you have an existing cluster, whatever. When they synchronize, instead of having them increment, what about having them grab the version number of the server that they're grabbing from? So if they're grabbing from version 3, their own internal version now becomes 3 instead of 2.
No, the way this was solved is that, we fixed this recently. We are also preserving the time of when the configuration was created and not when it was applied.
I'm curious, why not use the version of the server we got it from, so that we kind of treat it as the version number, as opposed to the number of changes grabbed
Okay. You can have some. Okay. Now let's stay on this diagram, and actually I'm getting closer to this. So let's say that you have now the configuration is 4, 4, 4, and 4 on all of them, and says that this one is restarted, so it starts at 1, and then it's synchronized from the other, and this becomes 2. So now we have 2, 4, 4, and 4. Says that now this one, you get the new configuration on this one. So this increased by 1, this becomes 5. The configuration is then pushed on that one, that becomes 3. And the other two, but this one can get the configuration from this one. Nothing stops it from taking the configuration from this one. So getting just the version number won't be enough.
But no, wait, because A would have grabbed its version from Delta, you said.
Yes.
Which means it would have grabbed it as 4. So A would have gone from 1 to 4. I'm not arguing against.
Yes, I see your point.
I'm not arguing against the timestamp. I would keep the timestamp. I think it's just different implementation. It could have been just like that. But like I would keep the timestamps, but I would also have the version numbers for the
There is another reason for this why it might not work. So now let's assume that they are all with the same version, and you manually connect to this one, and you run load MySQL server to runtime. You run load MySQL server to runtime. The version will increase by 1 because you made the operation, but this is still identical to all the others. So they will not synchronize because there is no need to synchronize because the checksum is the same. So locally, you can increase the version. But in this case, you are triggering some sort of synchronization that there is no need.
Yeah, I wouldn't think I would just bump the version numbers.
Still, you are synchronizing the version number.
Yes.
And I'm not saying no, just I know that the fact is that we had a history of issues and headaches, like why we had the configuration that got rolled back. And it took some time to troubleshoot why things like this happened. Thank you. So yes. Yeah, I mean, I have probably 2 more minutes if you don't mind. Okay, thanks. Yeah. Yeah, just the last 2 minutes probably even less. So as I was saying, like into 4, to avoid this configuration nightmare, we do not just synchronize. We synchronize the checksum and everything else, but also we synchronize the timestamp. So like if there is a configuration change, we are also shipping the timestamp. So the timestamp is the timestamp when the configuration was created and not when it was applied. Now, this is another thing that we solved. In the example I was giving before about the DNS and the load balancing, this is what was causing it and how we prevent it. So now before 2.4, what we were doing was a ProxySQL node was detecting a configuration change, waiting for the diff before sync to reach that specific threshold before triggering the synchronization. Then it was pulling the configuration and just applying it. Now the problem is, what if while pulling the configuration, like between the detecting the configuration change and pulling the configuration, actually the configuration on that other server changed as well? And this is possible. So what it does is, now in 2.4, what we do is not only we take the configuration, but we make sure that the checksum of the configuration we just pulled was the checksum that we were thinking that we were pulling. Yes. So says that the checksum of one specific server was A, while the checksum of the other server was B. It was waiting for 3 seconds by default to put the configuration. But then, by the time it was pulling the configuration, something was changing there. Like, for example, somebody was making a new configuration. And making new configuration could have also been like delete from MySQL server to then insert new servers. Probably were also the same server, but still there was a stage in which there was a delete MySQL server. So we could have the first proxy pulling an empty table for the MySQL server and applying it locally. So what we are doing in 2.4 is like, okay, we pull the configuration. Before applying the configuration locally, we compute the checksum of the configuration. And if the checksum is not B, that was what we were thinking to be pulling, we just discard exactly. No, we discard it, and we basically go back to the same algorithm. It's like wait. No. Yes.
And one was lagging behind, and it has different checksums. By the time that you actually want to pull it, it might have already changed.
Yes. And you know, this thing is also prevent situation, weird situation like the one I was describing before about DNS and load balancing, because if now is pulling the configuration, is making sure that the configuration has pulled is what it was thinking. And
runtime configurations as well, right?
yes, no, runtime.
So it's going to pull that first one that changed, right?
Yes,
The newest one.
correct.
But then the example you gave with the load balancer, that they were checking and then connecting to this, then they put the load balancer address in the ProxySQL servers table.
Yes.
I would never do that.
People can be creative.
I would always put the server names and the load balancer is just the way that external.
No, they were using just in ProxySQL server table, there was just the load balancer IP. Exactly. And yes.
So other than checking for conflict, does it do any other sort of health checks on the other nodes to sort of know if like a node is bad or?
No, but the fact that now we have this table, this one, it allows us to create any sort of extra tooling. Like you can be connected to any of the proxy and just get the metrics from this one, and you can connect to any remote proxy in the satellite layer. And you know, there are several iterations that we want to go through. But for example, one of the first things we want to do it is that once we have this information, we can then configure Prometheus with the new proxy that has been created.